In this video, we're going to talk about something called the normal distribution. The normal distribution is something we've already seen a little bit. It's this bell-shaped curve. And we use the normal distribution when we have something called a continuous random variable. And basically that's just a fancy way of saying that the answer could be any number. It could be a decimal, it could be a fraction, any number is possible. In contrast, we talked earlier about the binomial distribution, and the binomial distribution is what's called a discrete random variable, which means that it only can be used for whole numbers. So the normal distribution looks like this, the bell-shaped curve. It's symmetric. The mean, median, and mode are all in the middle, and the probability is 50% on each side of that mean, median, and mode line. So when we use the binomial distribution, we could calculate the probability of getting exactly one particular number. And we did that in Minitab using that middle function and putting the same number in for both. With a continuous distribution, though, like the normal distribution, the probability of being exactly any particular number is 0. And that's a little bit hard to think about because it doesn't really make sense that you couldn't land on any specific number. But this actually makes the calculations with the normal distribution a lot easier, and we'll see why that is in a minute. We have something called the standard normal distribution. That means that it has a mean of 0 and a standard deviation of 1. So we're going to use Minitab to calculate these probability values. A key thing that can help you decide whether you're using binomial distribution or normal distribution is to look at what you are given in the problem. For binomial distribution problems, we're given number of trials and probability. For normal distribution problems, we are given the mean and standard deviation. So we're going to do this example here. We have airport managers who have found the time needed to get passengers loaded onto an airplane. It's normally distributed with a mean equal to 15 minutes and a standard deviation equal to 3.5 minutes. Find the probability that loading passengers will take 22 minutes or more. So in my problem, I'm going to start by identifying the important information here. The mean is 15 minutes, and standard deviation is 3.5. And then the question is asking me to find the probability that loading passengers will take 22 minutes or more. So let's go to Minitab. And just like before, we're going to go to Graph and go down to Probability Distribution Plot, and then click on View Probability. So I'm going to leave this on normal distribution this time because that's what I want to use. Notice that it's giving me my standard normal distribution here as a default with the mean of 0 and standard deviation of 1. I'm going to change this to the mean and standard deviation from the problem. The mean was 15 and the standard deviation was 3.5. And then just like before, I'm going to click on Options. And then I have the option here of changing to specified probability or specified X value. In this problem, I want to find the probability. If I want to find the probability, that means that I'm using a specified X value. In this case, that X value is 22. And since I want to find the probability of 22 minutes or more, 22 minutes or more is going to be a right tail. This is going to mark 22 and then everything to the right of that. Now the nice thing about the normal distribution is that you don't have to worry about whether the 22 is included or not, and that's because the probability of any individual number is 0. So 22 minutes or more, or just more than 22 minutes, like 22 minutes and 1 second, those are going to have the same probability. So that's nice. So I'm just going to enter 22 for my X value and then click OK. Click OK again. And here is my result. Again, I can check at the top of the graph to make sure that what I've entered matches up with the mean and standard deviation here that I have been given. And then when I look at the graph, I see that X value marked at 22, and then I see everything above that. So this is 22 or more, shaded red, and the probability is above the graph. So 0.02275. Of course, I want to pay attention to how MyLab would want me to round this if I'm doing a homework problem. Rounded to 4 decimal places, it would be 0.0228. So let me write that here. Write my answer. So not a very high probability, just a little over 2%. So if the mean is 15 minutes, standard deviation is 3.5 minutes, that 22 minutes or more is pretty unlikely to happen. The next question says 95% of flights will be loaded in less than what time? Now this is a little bit different because now it's not asking me to find the probability, it's giving me a probability or a proportion. And it's asking me to find the x value. So this 95% is the probability, and less than what time, that's the x value. So I'm going to go back to Minitab to calculate this. Go to graph again, probability distribution plot again, view probability. I'm using my same mean and standard deviation values, so I'm not changing those, but I'm clicking on options. And now I'm entering a specified probability. So I'm going to switch that up there to specified probability. Now the question is asking me 95% of flights will be loaded in less than what time? So I'm going to mark a time here, and I want to know 95% to the left. So this is going to be a left tail problem. And my probability is going to be 0.95. So click OK. And here's my new graph. So I see my mean and standard deviation. I see the 0.95 above the red shaded area. And the red shaded area is the time that 95% is less than. So that's good. And I see that time marked on my x-axis, which is going to be my answer of 20.76. Again, paying attention to how MyLab wants you to round numbers, I could round that to 20.8 minutes. And so that is going to be my answer here. So that's how you use Minitab to calculate normal distribution probabilities.